Welcome to Industrial Ethernet Week 2. We are so excited to host this second annual discussion regarding the advancements of industrial Ethernet and how industry demands will continue to shape this technology in the future. I am Lucas Knapp, the Vice President of Product Management and Market Development for Harding in the Americas. Over the next 3 days, you will hear from experts across many industries, including engineering fellows, industry standards organization committee members, design engineers, and many more to discuss how they see the current state of this important technology and how would we see this shaping up in the future. How has industrial Ethernet changed and why? What are the most challenging issues being seen across the industry today, from higher data rates and faster speeds, and all while trying to get it as small as possible? How do we see future trends such as Industry 4.0 and new technology trends like artificial intelligence shaping the future of these products? We'll also be covering the roadmap and the new innovative technologies that are looking to solve those problems to help you and your customers adapt to these solutions. Over this 3 days, we'll be covering a few different topics. The first day, today, we'll be discussing industrial Ethernet trends, a view from industry leaders. We'll be looking at our global roadmap and industry trends. We have 2 industry panel discussions today. All of our panelists, I'm looking over to our panelists in the room. Thank you so much for taking the time. They're with us in our Digital Experience Center, and we'll be talking about digitalization. Day 2 is all about shaping the technology roadmap. We'll have a review on how interface solutions and cable assembly solutions play a role within industrial Ethernet. We have another industry discussion around the journey with industrial Ethernet and a specific use case looking at harsh applications. And day 3 is all about the future of industrial Ethernet and single pair Ethernet. And I will tell you, if this is the first time you're hearing about single pair Ethernet, buckle your seatbelt. It is an exciting conversation and will be the future of Ethernet. We have an update on where we've come in the last year, and we're also going to be sharing the single pair Ethernet industrial partner progress. And then we'll have a panel discussion on the adoption. Adoption has occurred over the past year, and how do we see adoption of this technology going forward? And finally, we'll have a technology demonstration to close. So with that, we're going to kick off day 1, industrial Ethernet trends, a view from our industry leaders. And with that, I'm going to turn it over to John D'Souza, our President and CEO of the Americas, and Ralph Klein, the Managing Director for Harding Electronics. Thank you so much for your time.
Thank you, Lucas. Good morning, everybody. I'd like to welcome the virtual audience as well as our in-person audience here. We appreciate you guys being here today. It's a cold but a beautiful day here in Chicago. We don't get many of these, very often. So we appreciate when the sun is shining and it's dry and there's no snow around here. So it's a good thing. And welcome back, Rolf, all the way from Germany.
Thank you.
Yeah, I'm glad that you landed safely, and you had a nice, interesting day yesterday in the immigration line, and just a couple hours just to get in.
But it was worth it, and I'm really glad to be here. And as you said, a great event, looking forward to it. Weather that you organized is perfectly fine, sun is shining, and so really looking forward to it.
That's wonderful. It'll be an exciting week, and I'd like to thank everyone who put this together. It's not easy to manage and coordinate a hybrid type of event, but in looking at the agenda, you guys got a number of experts here, and I believe it's going to be a really, really productive summit for all of you guys. Okay, with that said, we're going to talk about the industrial Ethernet. We'll start with that simply because we understand as we talk about single pair Ethernet, we know that it takes time to actually launch a new standard, adopt it, promote it, and so forth. And all we have to do is look at Ethernet. Here you see the 2 inventors of the technology. They call it the ether back then. In 1973, you see Bob Metcalfe and David Boggs, who unfortunately passed away last year. But they talked about the challenges they faced back then to get this technology up to speed. And the first project actually was to develop a network with personal computers and laser printers. And that was finally developed in the mid-70s. And then in 1976, they had a great white paper, landmark paper that came out. In 1979, now you think about it, now you're talking 6 years after that was developed. Then Bob actually started 3Com. He also developed a standard with IEEE. Xerox, Intel, and Digital, they started now adopting this technology 6 years later. And then you've seen all the performance improvement and the growth in the 80s. And then in the 90s, finally, you had the performance improvement. And then here we are, 2015, where single pair Ethernet begins. So, but to get this off the ground from 1973 to 1979 required a lot of work. A lot of work in trying to promote the technology and getting it adopted and developing an ecosystem as well as the standards to get it to where it is now. That's the journey we're on, as it relates to single pair Ethernet. But we feel really good about where we are today. We feel that we have an ecosystem of components and device manufacturers adopting the technology. And to show that in many ways, you can see here that we are kind of flipping the script. If you look at 2016, you look at field bus still being like the majority of in the applications, and industrial Ethernet at 38%. But you fast forward to 2023, we see that we flipped the script. You see Ethernet, industrial Ethernet at 66% and field bus at 27%. All of that in the middle of a pandemic, which many people would say that it slowed that process down, because when you got to get products out the door, the last thing you want is introduce new technologies to the market, right? So that slowed down the process a little bit, but still, you can see the progress that we've made. A lot of that is driven by Industry 4.0. And to that end, I'll pass it over to Ralph, who will share a little bit more about what we're seeing in the marketplace.
Perfect. Thanks, John. Now, you mentioned Industry 4.0, John, and the birth of Ethernet here in the United States. And for me, it's really a pleasure to be here and participate at this Ethernet forum here in the country of birth of this technology. And if you think about what happened over the last years, and there the pandemic really, I think, boosted the development of this technology in all dimensions, in business life, how many digital meetings we're having nowadays, and how well they are working. And if you think 3 years back, what a challenge that was to get used to these digital tools. Yeah, and nowadays, many of us could even give trainings how to utilize them. If you look to private life, the importance of Ethernet, I have 2 teenagers at home. If you choose the location where to go for holiday, for sure it's good if it's a nice hotel, but the Wi-Fi has to be a good one. Yeah. If the Wi-Fi sucks, you don't go there, or perhaps once. Yeah. So data, Ethernet, communication has become so important over the last years, and was very interesting, John, to see this development and that changes, technological changes, need time. And behind us here, you can see and read the definition of IIoT or Industry 4.0 from one source. And one of the keys is that you communicate in a different way, in a horizontal way, in a vertical way, that you connect different devices and things and people to each other. And we are, I think that's out, no doubt, we are in an industrial transformation. Many people call it the fourth industrial revolution. And our view on this is that where we are coming from, you can see here behind me the, let's say, traditional automation pyramid with the different levels from the ERP system, process level, input, outputs, and the sensors and actors on the field level. And that is how the automation pyramid is done today. And if you think about the definition of Industry 4.0 on the page before, we are convinced that that is not going to be the infrastructure or the architecture that will bring IoT into the future. It's too hierarchical, that's our view. And as well, you have too many languages in it, because if you think, and if you remember the slide that John D'Souza has shown before, for the different bus systems, you have all kind of different bus systems combined with Ethernet protocols and so on and so on. And you very often need translation between these different solutions. So you need translations, and very often you don't have directly access to the field level, to the IP device, to the sensor to really analyze and get data out of the sensor to digest the data, utilize it for whatever reasons that your application can be might benefit from it. So our view is that the automation pyramid changes. That's here a bit symbolized by flipping it around, and that you have these connections between vertical and horizontal devices in the pyramid, and you have the possibility to communicate in one language only in the whole pyramid. And the benefit is that you can analyze data, information, knowledge directly out of the field level and bring it into the cloud and utilize it for your use case. And what we are very much believing in, and that what was on John's page before on the right-hand side, is single pair Ethernet. That is a technology which came up 1995 roughly. At the beginning, it came mainly out of the automotive industry, because the automotive industry has as well a need for more data, less weight, less space, with all the sensors that you have for security, for vision systems, for navigation, and so on. And when we heard about that at the beginning, as a company was focusing on industrial connectivity, at the beginning we said, automotive, that's not our business. We are not delivering connectivity into cars normally. But then after reflecting for a certain while, we said, if it comes out of the automotive industry and you get the volumes and the cost for the hardware gets down for chips and PHYs and so on, then this technology has really the potential to change and to transform the automation pyramid. So one of these few moments where there might be some game-changing technology in the industry. Yeah, and I think the history that was shown for the Ethernet is impressive, and we believe that we are on a similar moment, perhaps not comparable to the birth of the Ethernet itself, yeah, but from a technological point of view of change. And we are really supporting that right from the beginning. I'm very happy that we have as well many supporters and panelists here in the room, and looking forward to this exchange over the next days, how to make this technology implemented into the industry. Because as John D'Souza has said before as well, changes need time. As well in the industry, changes need time. What you see here is many companies are basing for sure their business models on the automation pyramid as it is today. And changing to a new business model is as well always a certain challenge for those companies who are in this business today. And sometimes they will be challenged as well by others entering in, coming out of a different environment. And I'm sure that for the automation business, that will be many new challenges and opportunities with new companies coming in out of the IoT environment. And I believe and I'm convinced that especially the United States, with your strong startup culture and technological companies, will be very strong in this. And I'm really glad to be part of that as well. Now, if we look into what is coming in the Ethernet and as well over the next days, we are very much focused on solutions that you can see already today. So what kind of connectivity can we offer for today's solutions, and what kind of solutions do we have for the industry Ethernet of today? We are looking as well into solutions of tomorrow, which are already more miniaturized, more robust, which allow miniaturization for your devices. And then very much, and that is especially the third day that Lucas has introduced before on day 3 as well, we look on the industrial Ethernet of beyond. And that is, as we said, single pair Ethernet as the key driver and the key technology in which we believe. And therefore, I'm really looking forward to a very exciting 3 days, and I really hope that you'll enjoy it.
That'd be great. Thanks, Ralph. And you brought up a really good point. You know, we started with SPE in the industrial space in 2015, but the technology's been around for almost 30 years now, right, in the automotive space. That makes a huge difference because we're not starting from scratch. We're talking about a mature technology with volume. All we're doing is adopting that into our industrial space. So that's great. Well, now we're going to turn it over to Arnold, who is going to talk to us about trends within the industrial market. So without further ado, let's welcome Arnold. Ralph. Thank you, everybody.
Thank you, John. Thank you, Ralph, for this great history. Good morning, everyone, and welcome from Harding, North America headquarters. Today, in the next 10 to 15 minutes, I'm going to talk to you about the major trend that we see within the industrial market. But before we begin, let's go briefly through the fourth industrial revolution the society did experience the past 400 years. But let's just define that industrial revolution is a major changes and transition in manufacturing and industrial process with innovative technologies. So the first industrial revolution started in the 18th century, around the 1780s, where machines and engines were powered by water and steam. The second revolution, industrial revolution, happened in the 19th century, around the 1870s, with the discovery of steel, electricity, and later on, mass production and assembly line. The third revolution happened in the 20th century with the introduction of electronics, automation, computers. So our factory became more automated. And our factory became more automated. And this industrial revolution focused more on digital technology and industrial processes. The fourth revolution is in the 21st century. The current revolution, the current environment where we are, in which disruptive technology such as IoT, advanced robotics, virtual reality, and artificial intelligence are changing the way modern people live and work. Now, the Industry 4.0 is one of the most complex one and embodies a variety of disruptive technologies, such as artificial intelligence, big data analytics, cybersecurity, cloud computing, advanced robotics, and Internet of Things. And all those key components make our factory smarter, leaner, and more efficient. So why the trends are important and critical? When the fundamentals of your business start changing, talent skills, processes, technologies, then your business will be facing an inflection point. And as business leaders, you need to adjust your strategy and your business model to remain relevant and keep growing. Because doing nothing will be just the beginning of a decline. So let's go now to the first major trend that we see. So if you look 6 to 7 years ago, the number of yearly installed nodes, and understand that the network node is a physical device that is a part of a network infrastructure. An example could be a router, a printer, a server, a switch. So the number of installed nodes for the field-bus communication protocol was 58%. 6 to 7 years later, it drops to 27%. And field-bus communication protocol include field-bus, Modbus, or CAN bus. On the flip side, industrial Ethernet, the number of yearly installed nodes for the industrial Ethernet was 38%. And it did increase to 66%. This is a 28% increase. And industrial Ethernet communication protocol include communication like Ethercat, Profinet, or CC-Link. So now, what are the key drivers for industrial Ethernet? The first one is the proliferation of Internet of Things, where all the devices are interconnected, interrelated. You're connected to your home, to your watch, to your tablet, to your factories. The second one is the need of a unifying communication protocol between the IT and the OT space, information technology, operational technology. And lastly, is the efficiency. So Ethernet is the communication of choice that offers the best trade-off between the bandwidth and the reach. And this is why automotive has adopted Singapore Ethernet, like Ralph was mentioning, so 10 years ago, back in 2011. So what are the benefits of industrial Ethernet? The first one, it offers a seamless connectivity with an expanding ecosystem of Ethernet devices inside and outside the plant. The second one, it offers a deterministic communication that enables a real-time control and synchronization of mission-critical systems. The third one, it's a proven optical Ethernet that can deliver electrically isolated transmission up to tens of kilometers. And finally, the high bandwidth communication capable of supporting emerging data intensive application. The second major trend that we see is miniaturization. You probably recognize on the screen here the iMac back in 2000. On the right inside, we have the iMac 20 years later. Except that the difference here, the iMac on the right inside is 20 times thinner, but 20 times more powerful than the one on the left inside. Powerful in terms of speed, resolution, memory, RAM. If you translate that now into the industrial world, you will see the evolution of HMI, human-machine interface. From the right inside here with the box, all the way to the right inside with the tablet, without compromising the quality and the robustness of the product. So what are the key drivers for miniaturization? The first one is the space savings. Density becomes a more prevalent problem. So companies want to have compact solution and reduce space. The second one is the weight saving. You may not see the benefit on the computers, but if you reduce the weight in the vehicles, you can improve the efficiency with the gas mileage, for example. And this is the last one. Now, many companies, high-tech companies, including Harding, are facing this challenge. How do you increase the density? Reducing, in our case, the amount of cable you use, reducing the device, the size of the device, or the connectivity. At the same time, increasing the functionalities, speed, power, artificial intelligence, cybersecurity, while remaining competitive. So this is the equation many high-tech companies are trying to solve. And the last trend I would like to talk about is the hybrid solution trend. So on the right inside, you have a servo motors here with two circular solutions. In this case, is the M17. You have the power and the data. Here on the right inside, you have the same servo motors, but we want connectors. Hybrid one with power pins and data pins embedded. So what are the benefit, or what are the key drivers for this? First one is the density. So the need of a compact solution. when you bundle two products into one. The second one is the cost reduction. So you reduce the money. Instead of using two connectors, you use one connectors. So you can save, in our case, up to 40%. And the last one is the efficiency. So if you think about deploy that on the field, so it's more efficient to deploy one connectors and one cable instead of two. Now, I will finish with the question, how Harding is contributing to this fourth industrial revolution and the trends that we discussed earlier. Day two will have the answer for you, but I will mention three things. First, Harding enabled the industrial Ethernet connectivity by building a deep portfolio of solutions that will address all your applications with Ethernet base. Second one, we innovate, miniaturize, and compact solution without compromising the robustness and the quality of our product. And finally, we shape the future of IIoT with single pair Ethernet connectivity that we pioneer. Now, stay tuned for the next panel discussion where we have business leader expert panelists. And equally important, stay tuned for tomorrow, where we're going to talk about the innovative solution that will address the trend that we discussed earlier today. With that, thank you for your attention and talk to you soon.
All right, hello everybody and welcome to our first panel here at Industrial Ethernet Week. We have three great panelists for you, and our topic for this panel will be why digitalization is important for modern manufacturing. One quick note before we start for our virtual audience, if you have any questions, please feel free to put them into the chat and we will address them at the end of this panel. So we will start by introducing our panelists. Adam, would you like to begin?
Sure. My name is Adam Soder. I've been with Sumitomo Drive Technologies for 13 years now. I'm our product systems reliability manager.
Cool. All right. Mason, would you like to go next?
Yes, my name is Mason Khan. I'm with Rockwell Automation. I've been with the company for about 18 years, and I am concerned with the IoT. Thanks for having me.
Great, awesome. Cool. And
My name's R.C. Crosby. I've been doing industrial automation for about 25 years, and I've been with Pepperl & Fuchs for about the last 9.
Great. Awesome. Thank you so much. Well, now we'll kick it off with our first question, and that is, what benefits will companies achieve from adopting digitalization in their manufacturing process?
I'll jump in. I mean, one of the biggest issues that companies are facing these days are labor, right? Labor shortages. Unemployment being 3.3%, that's great, but you know, right now there's currently 2 job openings per available, per unemployed person at the moment, right? So the easiest way to address that is digitization, right? Automate that problem, right? If that's going to be an issue, take it away.
And another great example was the past couple of years through the pandemic. People weren't at the plants. It's only minimal people were at the plants for keeping operations going where necessary. But a lot of times everybody was working remote. Being able to access your plant's data, your production data remotely kept things going. I mean, as busy as it was, or as shut down as it was, we were still busy. We were still producing things. Many different industries were still busy. They had to connect to it remotely somehow. And this is the way to do it.
Just to latch on to it, I think pandemic was an accelerant for manufacturing companies to really achieve higher efficiencies. And it's not just the solution for pandemic, but it's a blueprint for how we go forward.
You know, one issue though that the pandemic did expose is we had a lot of institutional knowledge, you know, kind of wrapped up in 30-year employees that used the pandemic as an excuse to, you know what, I'm going to retire. Right. And so we've lost a lot of that institutional knowledge. And so that now should be codified going forward and put into the machine instead of relying on some maintenance guy with with his ear tuned to whatever frequency that motor's making, so he knows that bearing's starting to go out, right? Take that away, put it in the machine.
Yeah, that's really good. So you gave a really good example there of, a motor perhaps reaching its end of life, and digitalization can help us understand that and know when to have preventative maintenance. Are there any other examples of where digitalization can be used specifically?
So predictive maintenance, preventative maintenance. So the example I always use is the check engine light in your vehicle. It's the same concept. You see that light come on, you know something's wrong. Could be a million different things, but at least you know something's wrong. So if you take a gearbox, for example, that's the world I'm in. You take the gearbox, for example, that's moving a conveyor or moving automotive assembly, whatever the case may be. You don't know what's going on. To your point, that you have the older gentleman that just listens to it. He knows, oh, that's going bad. Well, that's too late in some cases. So getting ahead with a sensor, whatever that sensor is, vibration, oil level, whatever it could be, getting ahead of that failure curve keeps that production running that much longer, because everything has end of life. We know that nothing lasts forever. We'd love it to, but it just won't happen. So getting ahead of that P to F curve, that failure curve, is what we're all trying to do.
Yeah, you can build it in the downtime.
Yeah. Yep.
I mean, that's the $1 million question, right? Just, we know, or even when something's approaching end of life, okay, well, we shut down here. Then let's replace all this stuff that's within 80% of end of life. Do it immediately.
Right. Schedule it. Schedule it when you're already going to be shut down for a Saturday morning, that if you know it's going to take 4 hours, okay, we're going to be shut down for 4 hours anyway. Let's not lose any production. Let's keep it moving. Because some, depending on the industry, cost of downtime is up to $60,000-$70,000 a minute, sometimes a little less, 70,000 an hour, but still the cost of one of these systems is pennies compared to not moving a single product off the end of the line. So it all comes down to what the cost of your downtime is, how much it means to you to prevent that from happening.
I think this really hits home for me, because oftentimes we have a downtime and you can track it down to a simpler electromechanical components that are not being connected. Meaning that the only time you're finding it out is when it's too late and the production is down. And like you mentioned, downtime is really expensive, right? So the idea is that if we have those smaller devices are also capturing intelligent data and making it available to make smart decisions for the plant owners, that really enhances the productivity and the yield for that customer. So I see productivity as the biggest gain for digitization. I think it also helps the manufacturers produce products quickly to the market, because we're able to do prototyping faster. We're able to learn from those gearboxes, right?
Yeah.
Talked about, and incorporate that learning into our NPI cycles. So that really helps translate the efficiency to our customers down the road.
Yeah, great point. So really good discussion of some of the productivity we can have, right? Some of the ways we can make products better. When it comes down to like the KPIs, the performance indicators that prove that this is really having an effect, what can companies expect to see, as KPIs for the adoption of digitalization?
We kind of talked
Yeah.
about it earlier. It really depends. It depends on your industry, what you feel is the most critical asset to keep monitoring, to keep attention on, if you will, because they're not all going to be the same. The applications are slightly different. Even in the same industry, the applications are just different enough that certain things go wrong at certain different times. So the best answer I can give is start small. Just pick a few that are the most important to you, monitor those, and scale it from there. Don't do everything, because that's the first goal is, oh, I want to monitor everything. I want every little thing to be monitored and kicked back into my system. But half the time that ends up being useless data because you don't know what it means. So start small with the 2 important KPIs to you and take it from there.
And see, I think that's kind of the big issue, and not to take away from panel 2, so stay tuned to panel 2. That's probably going to riff on this a little bit better. But customers are looking at this overwhelming issue of, oh, I need data, and I don't know where to start, because they're not data capture experts. They're not data utilization experts. They just want to know that the machine's running really, really well. And so they can get really lost and bogged down. It's like, okay, start with the problem children. Start small, start with the bigger issue items that you have, and don't tackle the whole floor in one shot.
Yeah. I think I want to chime here too. I think it's important to start small, scalability, right? But we also have to be cognizant of the pilot purgatory, because many times we go into the pilot mode and the IoT project is going to stay there. So I think it's about being able to find templates or repeatability use cases and deploying it. Maybe if you're using it in your supply chain, maybe next adjacent one is your conveyor belts and the adjacent one is your quality control. So I think there's many ways you can deploy it and achieve the outcomes that we are looking for digitization.
Yeah, that's great. So this kind of iterative process of starting small, adding more, is this kind of the standard way that people have been adopting it? Or is this something that you kind of think is a better approach than what people are currently doing?
It's a mixed bag, but in my experience, they do start small after some conversations. So their initial suggestions, oh, I want to monitor absolutely everything. Give me everything you have.
Mhm.
And I usually have to rein them back in a little bit. It's like, okay, I get it.
Yeah.
But let's start small. Let's make sure it works. I called it a hand-holding process from our side. We're not going to just throw you a system and expect you to know what to do with it. We're going to walk you through it. We're going to make sure you know what the data is telling you. And then we'll start walking away. And if you have questions, let us know. But we're not just going to throw you a system with 1,000 data points. And within 6 months, we'll never hear from you again because you lost interest in it, or you got too confused or too bogged down with all the data in front of you. It's just not the best way to go about it. So there's a mixed bag, but I usually end up reining them back in.
Cool, great. So what type of systems or processes would benefit the most from Industry 4.0? We've talked a little bit about manufacturing in general. Is there anything that's perhaps more specific?
Well, manufacturing certainly seems like the first place to start, right? Because that's kind of, I don't want to say the easy one, but it is the most critical. If you're not producing, you're not making money, right? And so that's probably the first place to start. And again, how do we make the machine do the majority of the work, take the decision making and all of that away from the operator? And so that maybe you don't even need an operator. You can go fully autonomous, right? And then you're not worried about necessarily pandemics and having labor on the floor or retirement or, the great resignation that we had sort of the last 18, 24 months. Take that off the floor, take that off the production manager's plate, put it into the machine, and then all that data, all that can be analyzed elsewhere. Yeah, that's where I would start.
Yeah,
Well, could we show the graph?
yes, absolutely.
Because obviously you talked about some industrial segment or manufacturing segment. I think this is very critical. So this is a chart behind us is the US Labor Statistics Bureau. And what they do is that they track the productivity out of the American manufacturing firms. So we have about maybe roughly 250,000 medium to small size manufacturing facilities in America. And if you can see the chart, it started tracking maybe in the late 80s and so forth. You can see the productivity is rising steadily, right? And then around 2010 or 2011, it actually kind of plateaued. In some cases, it went down. And I think this kind of shows that we need to have more data inside to make sure this productivity curves continue to rise. Because from the 60s to 2010, it was the rise of the Industry 3.0. And we were using the robots and the PLCs to, get the every little dime and nickel out of your productivity from your factories. But now that's not enough. We need more insight. We need insight from the things that were not providing insight before. And only then we are able to go back into the curve that kind of continuously going towards the north.
Yeah, absolutely. It doesn't look like there's much room there at the top of the graph, but I'm sure that we can.
You fix the scale.
Yeah, there you go.
And one of the things we can to consider too, as scalable as the system is, it's the same hardware. So you can start very small in whichever part of your operation and literally copy and paste it. So you change maybe the data, type of data, whether it's vibration, temperature, amp draw, whatever the data point is, but you can take the exact same hardware and literally copy paste it. So once it's working in one part of the plant, you can easily copy and paste it to somewhere else. And that's kind of how certain industries have taken it. They'll do final assembly versus sub-assembly. They'll start in one and just move it to the other. So a lot of the systems are very scalable in themselves, the way they're designed.
Yeah.
So it makes it a little easier to spread to the different industries.
Ultimately, though, then digitization becomes sort of the check. If you're ever going to go autonomous or lights out, it becomes that the checking factor that, okay, we still are in production, everything's running, everything's working great. We have harmony across all the different machines on the factory floor. Digitization is what is going to do that.
Yeah, that's very interesting. And so it's definitely understood that, there's not really a significant hardware investment that needs to be made. But what about from a knowledge perspective of like a factory's current employees? Would they need to get training on how to incorporate the digitalization, or is this something that can be handled, let's say, by a third-party contractor or something like that?
I think one of the benefits of the IoT, or particularly the single pair Ethernet, as Ralph mentioned, we'll talk about it on day 3, is simplicity, because you understand that we're going through a shift of labor. And if the new technologies, modern technologies are not easy to implement, easy to use, there are going to be a huge amount of upskilling or reskilling. And our job as industry consultants and advocates is to make sure that it's easier for entry-level production people and so forth. And I think IoT will go a long way, help with that.
So I think a lot of that, it depends on the manufacturer as well, like of the system. So I don't know if we can pull my slide up there.
Oh, yeah, of
The
course.
one display that we have
Hold
on
on.
our system, this one in the center right here, that's the output right there. So you don't need to be a vibration analyst. You don't need to be a certified inspector. You just look at that. As long as you can read your colors, you know what the condition of your gearbox is. So the blue line is the actual condition, and the color in the background is your condition, green, yellow, red. So as long as the system is set up that way, which most of the time it is, the system we developed, our CycloSmart system, it is pre-programmed so that you don't need to be an expert. So if you if you partner with the correct company, I think it will make it as easy as possible, because we know that not everybody's going to know what this data means. If we gave you a raw frequency spectrum from a vibration sensor, not every maintenance tech, or some will be better than others, they would understand it, but they won't know what it means. But if we give them a system that's easy to read just by looking at it, it makes it easier. Then from here, it's just moving the data to where it needs to go.
Go ahead and throw mine up.
Of course,
Might
of
as
course.
well.
Yeah.
No, in the introduction, right, we had the two triangles, right? The one regular and the one inverted, right? And so the products that we make and most of us make, they're kind of on the floor at the lower level of the triangle. You can kind of see that's vaguely resembling a triangle, up there on the screen, And so our products, they live out on the floor with the operators, and in many cases, they've already been using an intelligent device, even though it's not networked with all the other intelligent devices. So as far as an implementation hurdle, they've already been using intelligent sensors and things like that for the better part of a decade. So from an operator's perspective, there's not much for them that need to learn how to do differently. Does it incorporate into the PLC a little differently, or is it, the travel path from the information from the sensor or from a gearbox to the cloud? That may be something that's different, but it's not unovercomable, if I can make up a word.
Yeah, we'll allow it. We'll allow it.
Yeah. But generally, I think we're also seeing a theme of the automation to autonomy, which means that it relies on less of a burden on the factory worker. The system is able to make some rudimentary basic decisions, like from your drives and for some of the devices, sensors you talked about. And if we have enough information, we are able to do the AI ML and do the next logical action. That means it's kind of a bit easier for the production worker or the maintenance personnel to tend to the machines.
Yeah.
And a lot of these systems do the thinking for you from analysis standpoint. All the thinking is done way before it even gets to this level. So when it gets to transmit it to that level, it's just a number at that point. It's just data transfer. The thinking, the AI is done at the lower level, to your point, right at the sensor level in some cases. So it makes it even easier.
Yeah.
And that I think is the future direction, at least from the edge where the operators are. There's going to be more intelligence in the actual sensors, in the actual devices out on the floor and outside of the panel, as well as those things are all going to do much more than what they have traditionally. You think sensor fusion and things like that. A lot more of that'll be taken care of within the device itself, and then extracted to the PLC or to the cloud via whatever pathway that is.
Yeah. Yeah, those are really good points. And the one way I like to think of digitalization is it's not some great big replacement that's coming in where everything shifts out and you need whole new employees or a different, set of workers. But it really is taking what you currently having and maximizing the efficiency of it. Would you guys agree with that statement?
Absolutely.
Absolutely, yeah.
That's a big roadblock we have. That's usually the first comment we get in one way or another. Oh, you're trying to take my job. No, no. We're trying to help you out. We're trying to help your maintenance guys out because we understand if you look at some of these assembly lines, just picking any assembly line, they've gotten so complicated over the years. One guy can't monitor everything by himself. We're just giving him an extra tool for his toolbox. That's all we're doing.
By the way, jobs aren't automated, tasks are.
Yeah.
So we're just automating a task or digitizing a task, not a job. So for whatever that argument's worth.
So we have the incredible infrastructure already built, and we can easily deploy the condition monitoring sensors to monitor it to get better efficiencies.
Mhm.
And there is no need to replace something that you installed 5 years ago.
Yeah, definitely. Definitely. Okay, it looks like we do have a question from the audience here. The question is, how many products available to order does each of the product companies, excluding Harding, let's take a step back on this one, on the panel have today? You guys want to talk about the product offering for you guys for digitalization?
Sure, I could start. I mean, so the one on my slide there is our CycloSmart system. So that's the heart of our condition monitoring. It's one product to answer the question. It's just quantity one, but it covers, as you see, all our gearbox products as well as anything hooked to them. So motors, the conveyors, and pillow block bearings. We made it so that it's expandable from not just one asset being the gearbox, but we're doing or not one component, I should say, and we made it expandable to all the asset. So the whole application can be covered with one module, one diagnostic unit, if you will. So it's one product to answer the question, but it covers anything you can throw at it.
So it's a little bit more complicated for me. We have 35,000 product lines within my division. And I would say over the last decade, the overwhelming majority have been built with these capabilities. So it's probably 60% of that, 35,000 to, it's a couple.
I think this is really easy for me to answer. I work for Rockwell Automation, and we are the providers of the industrial automation. And anything you can think from the edge to cloud, both hardware and software, is available for sale. Particularly, the trend is really the intersection of the hardware and software, like ThingsWorks or the factory talk analytics devices, are really critical in the light of what we were talking today.
Yeah. That's great. That's great. So this goes well into our next question. Why is now the right time for digitalization? Is it because the hardware is available? Is it because the value that we can get out of the processes has hit an inflection point? Is it just a natural progression of the industry where we happen to be right now? What do you guys think about right now being the right time for digitalization?
I think it's a combination of many things. We spoke about earlier, scarcity of the labor, right?
Mhm.
We talked about the changing dynamic of the customer. They would want to have different dynamic requirements, as we saw in pandemic, from the simple toilet papers to paper products. And I think it's about increasing productivity of our factories. It's about able to quickly comply with the quality and the compliance requirements. So I think the time is now. The technology is viable for implementation and it's ready. So yeah.
I think the past 2 years has fast forwarded it a little bit. It was already there. And I think, in my opinion, it was already there because the cost has come way down from just strictly a sensor standpoint. The sensor cost has dropped significantly. They can make tons more sensors for much more cost-effective values. And being able to remote monitor them the past 2 years just went through the roof. It's cheap and I can do it from home. I'll do it. And then just the cost of downtime. I mean, these just automotive, for example, it was brought up before. Automotive industry is insane right now. We're staying busy, and you shut that production line down, that's thousands of dollars every minute. So being able to just realizing that and seeing that the cost of these sensors is so cheap compared to that, They don't even think about it. They just give me one, you know, they just order one. But it's,
To, to kind of highlight his point, our photoelectric sensors, whether you buy a legacy 18 mm snout, just discrete on-off sensor, the list price is just about the same as our IO-Link intelligent sensor.
Yeah.
And it's been that way since they were introduced. So I think it's a customer education thing too, because they think, oh man, it's going to cost 2 or 3 times more. I've heard that 2 months ago, and so it's on us to go educate the customer base that no, really, it's about the same price.
Yeah.
And in many times it's, oh, by the way, those sensors you installed last year, now you can take them to this block, take them to this network switch, do this, and now they're all intelligent.
Mhm.
And so in many cases, they've already installed a intelligent, capable device, because I mean, essentially, we just don't make them anymore. Just some legacy stuff, but we don't make them anymore.
I see you made a really good point about, the cost points. And I think from a value standpoint, we have the OEMs who produce the technology, and then we have the consumers and users using the technology. And I think IoT is at the right place at the right time, that is really cost effective for the OEM group of people and also for the end users. So we are able to deliver the end user kind of the outcomes, which is the faster time to market and diagnostics for them to run their factory smoother, but also for the OEMs that the cost points for them to deploy those assets is really there. Now, the cost of an ordinary product or a connected product is very similar. So I think you're absolutely right. It makes a lot of sense to go pursue it now.
Really good points. Wait, go ahead.
But also, I think, just in our personal lives, we're used to it, right? We have smart thermostats. I had to buy a dryer last year. It's a smart dryer, right? And all of these different sort of normal appliances that we have in life, they're all smart doorbells and locks on our doors and stuff like that, So I think in our personal lives, we're just more than used to the adoption.
Yeah.
Why can't that matriculate to the factory floor?
Yeah. I think that's a really interesting point about how this isn't something that people are, pushing in manufacturing to change it. This is something that's happening everywhere in every single part of our lives, and it's just getting adopted by everything. And this is just kind of how it's getting adopted by the manufacturing process. And it's really exciting, especially in the beginnings of this transition, to kind of be a part of the industry to see it take place as a.
there's no stopping it, so you better be ready for it.
Yeah, there's no stopping it, right? Awesome. I think we have a follow-up question from the audience regarding the question on product portfolio for, we'll say, all the members of the panel. Are there SPE products available in your product portfolios now?
For me, I can say at the moment, no, nothing that's deployed. It's something that I imagine we're looking at, but as far as stuff that's deployed, not at the moment.
Okay.
I think the answer is similar for Rockwell. We actually have products in the works that should be available in the market in less than 2 years.
Working on
it.
Yeah. Still working on it.
Yeah, this is a really good point, and we're going to keep talking about single pair Ethernet through the course of these 3 days. So if you want to understand how it's being implemented and really when the adoption is going to take place, please stay tuned. We'll be excited to talk about it. Another question about IO-Link products. Can we explain a comparison of IO-Links to SPE?
So IO-Link's more point to point. So it'd be the sensor to a block or things like that. And in which case the block then would be, Ethernet to wherever it's going, whether that to be a gateway or a network switch or to the PLC. So that would be kind of where the SPE would come in. But the IO-Link communication between a device and the block, that's sort of more point to point.
Right. So I would see IO-Link and I would think input output, right? So it's really kind of that connection between the two, where the SPE is more of a hardware.
More of the network connection.
Next level up.
Yeah.
Mhm.
Okay.
Yeah, I would agree.
Very interesting. Cool.
Well, I'm gonna chime in too.
Yeah.
I think single pair Ethernet is also really interesting, that it's just a different physical layer. We have the Ethernet, industrial Ethernet, like Ralph and Arnold talked about earlier. is deployed already in the Industry 3.0. Now you have the same language all the way from your MRP or ERP layer all the way down to the edge of your factory, like a sensor or a push button or a contactor, right? Speaking the same language.
Yeah.
So that's also kind of shows the strength of the single pair Ethernet within the industrial Ethernet.
Yeah, that is really cool. Are the benefits for that going to be seen more on like the employee side, being able to understand every single network that's going on? Or is there actually benefits from the hardware itself to be able to communicate more efficiently?
I think both. I see for the Ethernet, since there is no conversion, right? You're not going from, now IO-Link is fantastic, but you have to go to IO-Link master and then to an Ethernet device.
Mm.
In this case, you're speaking the same SIP language, if you will, all the way from the bottom end of your, or the edge, close to your edge, and to high value asset like a drive or something like that.
Mhm.
So I think that makes it easier for a user that the UX is the same from one device to another.
Yeah.
So like earlier, we talked about reducing the learning curve, right? So I think this really plays into that.
Yeah. Yeah, definitely. Do you think that like the fact that Ethernet is so prevalent in every device that we use, like at home, right, in the office, that perhaps helps spur the adoption of Ethernet kind of everywhere on the factory floor as well?
I think so. It's, I think there is a lot of things that are happening in the single pair Ethernet, which we will hear day 2 and day 3, like cybersecurity, right?
Mhm.
And safety and the ability of bringing everything together under one protocol. I think that goes a long way.
Yeah.
So I'm really excited and just can't wait.
Yeah, definitely. Definitely. I know I used to work for Rockwell Automation earlier in my career. And I remember just juggling all the different bus networks, right? And all the different control net, device net, Ethernet, and being able to kind of go to shave that down into one network, I know would be at least efficient for my previous role. That's definitely going to be a benefit. So it looks like we have another question. And it's asking if STE products will be available in less than 2 years, and that is about the time frame that we're thinking about installing
But
that.
you know,
Right?
hold me accountable for that.
Yeah. We'll say it's an overview. We'll
yeah.
say it's a high level prediction.
I think we should have, I'm actually working on the project, so I can say with some certainty, we will have products available in less than 2 years' time.
Awesome. Cool. Cool. And then another question about SPE only using CIP. Is that something you're familiar with?
So actually the benefit of using single pair Ethernet is that we are able to use the SIP protocol, whether you're running the full stack using TCP and UDP, or if you're running the half duplex in the case of T1S. And it is SIP, which is fantastic because it's easier for routing and switching using the existing hardware. You just, it's different physical layer. I see it as a huge advantage. And quite frankly, I think that's going to be a leverage for us for adoption. And hopefully that answers the question.
Yeah, definitely. Cool. All right, great. I mean, are there any other benefits when it comes to, digitalization and, the manufacturing process? Is there anything else that people may not be considering about the benefits or about the challenges for adoption?
The biggest thing, I don't know if we covered it yet, but the biggest thing is that the concern we get is the security side of it. Cybersecurity, that's a huge thing for everybody. You're not allowed on my network, I'm not allowed on your network. That's okay. We can work around that. We understand that it's an issue, but there's plenty of offerings out there where they're not on your network. They're completely separate. They use cellular modems or whatever the case may be. So yes, it should be a concern, but don't completely shut it down when you hear that it's on your network. It needs to be discussed, but it shouldn't be a game changer. It shouldn't change the way you look at data collection. Yes, IT needs to know about it, but it will help them too.
And not to again oversimplify what we're doing here, but ultimately it is an insurance policy against downtime. It's you're ensuring efficiency, if you will, when you implement these processes and in these devices, these intelligent devices. That's ultimately what you're hoping to achieve.
I think some of the modern technology is built into the single pair Ethernet, whereas in the past it was sort of bolted on top of it. So if you're designing in like cybersecurity we talked about earlier, right? It's designed into single pair Ethernet, which means it was designed with that thought in mind to make it secure. I think that goes a long way, both for cost effectiveness and also for further optimizations. That makes it easier for deploy and everything.
Yeah, definitely. I also think that, with how everything is so connected, right? There's Teams meetings and Zooms meetings. Obviously, cybersecurity is an umbrella that needs to incorporate all of that, right? And so if Industry 4.0 is a part of that umbrella, right? It's not necessarily kind of a new, frontier that you need to be, aggressive against. You just need to acknowledge it, make your backup plans for it, make sure it's addressed, right? Yep, cool. Very good. All right, we have another question from the audience. Well, it's a good one. Can you each give an example of the importance of digitalization to your own business and what you've implemented? And also, how did you start? Where are you on your journey?
I'll go. So in 2016, we decided that we were going to move all of our products from Cleveland, Ohio, Twinsburg, down to a new facility in Katy to be closer to the ports and things like that. Built this 21st century excellent building, and as a fully automatic storage and retrieval system in there, as also product is the conveyors in there as well, all intelligent. And so that is, I mean, we can run lights out with that. We currently just only run about 16 hours a day with that, but it is something that we can run lights out and deliver product all day long to the Western Hemisphere out of that. And then we have another one in Singapore that does the Eastern Hemisphere. And so that's the big one for us. I mean, it is the guys who run that facility, they can watch what's going on with that on their phones and things like that. Because obviously we've got to practice what we preach. We've got to do those things. But that's a big thing. And if anybody's in the Houston area would like to check that out, let me know. Happy to give tours of that. It's an interesting experience. Has LiDAR for collision avoidance, positioning systems, things like that, all that. And at night, the algorithm repositions the products that are due to ship or high volume products, repositions those products towards the front, towards the conveyor side of that system. So that, again, efficiency, first thing in the morning, it's going to pull the orders that it knows it's got to ship, and or all the high volume items, they're all right there in the first bays, ready to be deployed the next day.
That's great. So you're practicing what you preach. You're actually
a little
implementing it
bit.
in your shipping process.
yeah.
That's awesome.
So at Rockwell Automation, we have a factory in our headquarters in Milwaukee location. And we're actually producing the contactors. These are the devices that make motors stop and start. And we're utilizing the full suite of the AR technologies and the IT and OT technologies. So we can visualize the waste, if you will, if it's happening and where it is happening. You're able to optimize if there is an issue, if one of your conveyors are kind of needs to be oiled or tuned. And all of that is happening without too much intervention from a technician, if you will. And I think it's really we're able to achieve really high level of productivity and able to have really small footprint of, where you can actually really do the human interactions. And it's fantastic. I invite all of you to come check it out. We usually have tours to show how the technology works using IoT 4.0, and it's fantastic.
So for us, we're Sumitomo Drive Tech, we do gearboxes. So we're a little less high tech, if you will. We don't are all hands on. We're very manually assembled. So we don't necessarily have the digitization just yet because we don't need it we do for our inventory. All our inventory is all counted and then digitized that way. But more recently, we're adding one of these systems that I showed to our test bed. So we'll be able to share the data live with our customers, no matter where they are. So a little different than these two companies, but we still see the need for it just because the demand is out there, and we're ready to support customers in doing this digitization. They're not by themselves. We're going to help them through it.
Yeah, that's great. It's also, I really like the idea that you guys have examples that can be if you're in the Houston area, you can see the tour. Obviously, Rockwell Automation has nice examples as well. But it just goes to show that this is going to be something that is going to be happening. And that's, if you want to get more comfortable with it, there's a means to be introduced to it. You know, companies are happy to kind of show you what's going on. Obviously, you're joining this Industrial Ethernet Week right now to learn a little bit more. Yeah, cool. So I think we're almost running out of time here. Do you guys have any closing thoughts before we wrap this up?
Just start small. That's all I can reiterate. Just take baby steps, find a partner, a company to partner with. We will, for example, Sumitomo, we will help you walk through it. I'm sure say the same for Rockwell and then
Yeah.
PNL. So CNF. So just find a partner, start small, and it will make it work.
And have an open mind, you know. Of course, there will be some challenges, but there is a lot of ecosystem is rich with the capable individuals all across the table and everywhere. So just be an open mind, and I think you're going to be amazed by the amount of efficiencies and productivity gains you will see.
And don't think it's quick or easy. It's going to
Yeah.
take some time.
And obviously that leads to panel two, you know.
Mhm.
But, you know, there are a lot of reasons not to do it. There are a lot of reasons to do it, you know, and so it's not gonna get any harder than it is today. It's not gonna get any less expensive than it is today. So it might just be worth taking that first step and getting started.
Definitely. And if you guys do want to take that first step and get started, there's three people very happy to help you out with that.
Absolutely.
Great. So thank you guys all for tuning in. We were going to take a short break, and afterwards we are going to have another panel, a new panel on the future of digitalization. So thank you guys again for tuning in, and we will be right back.
Well, hello and welcome back to the part 2 of our digital panel discussion. Our previous panelists did an excellent job of certainly defining what digitalization is all about. They've also expanded on the many impact or benefits that this technology has on modern manufacturing. So we're going to expand on that. And so for this panel discussion, we'll actually talk about some of the challenges that the industry continue to face in terms of getting to the mass adoption stage. And how do we overcome that as an industry? Because we all know there's been so many great technologies, but yet it takes a while for us to start reaping the benefits. We talked about the industrial Ethernet and whatnot. And then, of course, we'll also expand on some of the existing technologies that are available today in the market. As a reminder, again, so to our virtual panelists or to our virtual audience, if you should have any questions at any point in time, again, please feel free to drop them in the chat and we'll try to address them as best we can. So let me first go ahead and make an introduction to our panelists. Maybe you guys can go ahead and introduce yourself.
Sure. My name is Bill Martin. I'm a business manager for Rockwell Automation. I've been with the industrial automation industry for about 30 years, even though I'm only 30 years old. I can't believe that.
Yeah, you started when you were when you're 1, right?
Right, exactly.
Good morning, everyone. I'm Al Baidoun, President and Executive Director of ODVA. I've been with ODVA for 5 years, and prior to that, I've been in the automotive industry 30 years. So I've seen the journey from hardwired connections to LIN CAN communication to Ethernet. So it's good to be in the industrial automation to see the journey happening here as well.
Good morning, Steve Kaminsky at Banner Engineering. Thank you, Nazario, for inviting us in as the panel. Hopefully we're going to be informative. Been with Banner Engineering for about 23 years and selling in automation for about 33 years. And hopefully we can bring some insight into what we're seeing as far as what's happening with the technology and with the Internet of Things going forward.
Well, it's a hot topic, right? I mean, just a backstory. We were at a conference about maybe a month ago, and we're talking about digitalization, Industry 4.0, and we're just talking about, we know all the great benefits that this technology promises to the manufacturing sector, but yet we've been talking about it since 2011, and we're now in 2023. And along the way, a discussion that involved 2 people, next thing you know, there's probably what, 2 or 3 or 4 that just came into the discussion. And then I said, I got an idea, guys. We actually have a panel discussion or a summit specifically about this topic. And so I invited these gentlemen to expand on what our panelists talked about in the first panel discussion. And so with that, maybe a good start for us would be you guys providing us your vision of what digitalization is all about. I'll let you take the first crack at it.
All right, sounds good. Thank you. So from a Rockwell Automation perspective, I want to go to 2 slides. You know, our goal is we want to help our users or customers actually implement Industry 4.0. We would call it the connected enterprise. So we're trying to bring the connected enterprise to life with them, and you can do it. You can do it today. The technology is available. And what that means is we want to bring secure information from devices down on the plant floor, bring it to the right people, the right manufacturing processes, even up to the right analytical technologies, and just help our end users become more efficient at what they do. And unfortunately, I've seen some real world examples where, especially in very competitive industries, where those users or customers that have not implemented a version of Industry 4.0, I mean, they're no longer here today. So if you're going to survive and if you're in a highly competitive industry, this is something you can do to really make yourself have a competitive advantage.
So our previous panelists talked about, gave us examples of existing solutions today that can support digitalization. So it's no longer a vision, but actual reality. Can you give us maybe examples or expand on what Mason talked about for Rockwell Automation Solutions?
Yeah, sure, and I'll be happy to. So at Rockwell Automation, if we go to the next slide, we offer the hardware products. This is underneath our Allen Bradley brand. So we have the right programmable logic controllers, a lot of smart end devices, whether it's from motor control, industrial controls, any kind of power control stuff.
Yeah.
And you know, we can bring all that into the control system in a very easy manner over an Ethernet network. But the key is the next slide, right? So we have all this data, it's in one spot. But how do you get it up to the place where you can analyze it and where people can actually view it? And that's with our Factory Talk software solutions. I mean, that's really the glue that can bring really anything up into an analytical enterprise, not only for Rockwell Automation products, but for other products that can communicate with our control system as well.
So let's talk about that a little bit. So we talk about Industry 4.0 as being big data analytics. And again, our previous panelists sort of talked about, yeah, there's so many data, but what's actually important? Because you could easily get lost in the shuffle in terms of all these available data, right? And I think some of the things that you guys talk about as a company is minimizing the risk for our end customers so that they're more apt to actually adopting the technology. Can you expand on that? What type of data is most important? Obviously, it's going to vary from company to company, but if you were to select that specific data that our industry can use now, what would that be?
Yeah, you know, I guess there's a couple points. You know, our sales guys go, and we usually have a pretty intimate knowledge or relationship with our customers. We pretty much know how they operate, and we try to really understand what's keeping them up at night, causing them unplanned downtime. Once we identify those, what's really keeping them from producing their products, let's focus in on those 1 or 2 things that is doing that. So, for example, like at a paper manufacturer, I mean, a paper machine is $100,000 an hour of unplanned downtime.
Yeah.
And it takes about 4 hours to restart a paper machine. I mean, it's a huge mess. You don't want that. So if you could do anything to prevent that paper machine from shutting down, you know, it pretty much pays off a system instantly. I guess another avenue would be from a sustainability perspective. It's a pretty hot topic right now. So anything you can do to help save on energy and the environment, that's another avenue. Just to kind of get into the IoT space. I think that's a great way to start. Hey, how can we reduce our electric bill, not only to you know, save you on your margins, but to also help with the environment.
No, I mean, those are great examples. Again, in terms of defining what KPI is most important for your customers. And I think it was Mason that talked about keeping it simpler, I think it was Annabelle. I think it was all of them that actually start off in small chunks and then build from there.
That's right.
Steve, you want to add on to?
Yeah, if you want to bring up our slide, there we go. I'll start with the other side over here. And basically, you've heard it earlier, start small. And where most of the people are starting out is they'll come to us, they'll talk about large opportunities. They're thinking big. They got big ideas. They have a lot of ambition. They want to go down that path. That's great because that's going to get you thinking down a path, a future path for where you want to go. It's going to start that mindset of what do you need to, what's your kind of your end goal? And then start small, because you're going to buy thousands of sensors. Guess what? You put them on one at a time. So start small, measure those KPIs that you have with that small example, figure out what you're doing there, and then you can go ahead and move quickly. So think big, get your big picture, get your mindset where you want to go, what your goals are. And that's one of the biggest things that keep people from going down the IIoT approach or the Industry 4.0 approach is they don't know what they want to do with the data, or they're told gather data. And so they don't know, they don't have the belief in that data yet. And so once they start to understand that, yes, it's a huge factory. Think big, think about what you have to do. Think about what that game plan may look like, but don't commit to that yet. Start small.
Because it becomes overwhelming. And then that point,
yep,
right?
You start to stall out, you pause, you go, oh, maybe we should get more people to think about this and get in on this. And then that whole process just comes to a grinding halt. And so waiting for somebody to make that decision, that's where the start small comes into play. So whether it be products that we may have, products that other manufacturers have, it's the same concept. Make sure you have your roadmap, understand what you want to do with the initial data and where you think it'll take you, because it'll change. But at least be thinking about that roadmap of what you want to get out of it. And then you can go ahead, and then once you've proven it out, then you can move fast. And the guys were talking a little bit about it in panel 1 too. Things are changing so fast that are out there. And change is not a reason to just pause and well, let's wait for it to all sift out in the end and figure out what the best solution is. So you don't have to be afraid of the change, but you also, one of the things that happens quite a bit is you start to go down these paths, you do that kind of that pause because you're just not sure. You don't want to embrace it. You don't want to get into it. You don't want to look at, well, what's the impact going to be? So we have a lot of customers, and I'll go to the other half of our slide here right behind me. We have a lot of the customers are looking at and saying, how do I hold this in? How do I start to gather information? And one of the core elements, one of our visions at Banner is we don't want customers to have to change their direction they're already going down. They're already using a Rockwell solution for a sensor. With RC, if they're already using like a Pepper and Fuchs product, that's great. You've already vetted it. It works well. But you want to blend that in. You want to move that from an island to something that is actionable with. That is where you can take, and that's what we try to produce products in that direction that allow you to connect any type of sensor that's on your plant floor, bring it into a network, and then take that information and utilize that again. That gives you a chance of using what you have. So you can think big. I want to do all this.
Yep.
I can start small with what I already have. I can convert that signal over and I can move it into something that's actionable for us going forward. And that's really the direction of it. And then at the top, we're kind of talking about the inverted pyramids and pyramids.
Yep.
So if we look at it at the very top of this, the consumption element, everything below consumption, really the end customers don't care about today. The engineers, they care about that and making that work on the plant floor, but who's going to digest that data? He really wants that data. He wants to be able to consume that properly, whether it be for maintenance, whether it be for OEE purposes, whether it be just, information on what's happening on the plant floor, getting information to a supplier about, their delivery into you. That's kind of the end goal is that. And a lot of us get stuck getting to that end goal. And a lot of the customers get stuck in there. And we have to move them past that and get them to that data point where they want to arrive at is here's the data, I want to get to this. So our goal at Banner, our vision is basically move stuff off of a network, or I'm sorry, not off of a network, off of an island, bubble it up and get it up where it can be actionable data.
So again, it speaks to the whole simplification, but yet giving customers the freedom to sort of choose. But I guess
Yep.
that brings in standard organizations such as ODVA.
Yes.
I think it's very important, in my opinion, for all these different technologies to be somewhat speaking the same language, which we address with SPE, single pair Ethernet, right? So Al, what role do you see ODVA playing in ensuring the adoption, that everyone is playing nice, right? Speaking the same language, so that in terms of, again, implementing the entire solution, we make it easier for our customers.
Sure. If you can move to the slide. And so ODVA, we're an international standard development organization, and we are committed to the digital transformation industry 4.0. And panel one did a great job talking about the need, why we need it. And organizations like ODVA, we are offering the solutions. So I want to start with Ethernet IP as an industrial protocol. And there was discussion about single pair Ethernet. So it offers a complete solution for the automation industry, whether it's hybrid, whether it's factory or process. Then the next important step is this is something we value, that it is open, it is a standard, and it's a standard Ethernet IP, a standard Ethernet, and you have SIP, the Common Industrial Protocol, running on top of it. So the physical layer can change, but the communication is not impacted by that, and that's why we can transition into single pair Ethernet easily, just with change to the physical layer. We are making the data available for everyone to do whatever they need to do with it. So we're basically providing the transparent access to the data for everyone, for manufacturing operations to use. And as a standard organization, we're continuously working with our members, with close to 400 members representing the largest organizations, industry companies worldwide. We bring the talents from all these organizations to come together and help to develop these standards so they can be available and they benefit everyone in the industry. So, and obviously, because we are a standard Ethernet, unmodified Ethernet, the Ethernet IP does support the network conversions, the OT/IT journey. So on the next slide, I will speak specifically on some areas where we really made a difference, and that is, we wanted, the goal is to make sure that Ethernet is reaching devices at the field level, everywhere, a device or sensor actuator is being used. So two examples, Ethernet APL, basically offering the single pair Ethernet solution to the process industry. And that is, basically, an area where it really needs it. It's offering a solution that you can get Ethernet up to 1,000-meter distance, and power and signal over the same twisted pair. So getting a smaller wiring into areas and intrinsic safe conditions as well. So this is one area. Another example of an SPE is getting Ethernet down to hardwired, small devices. We call them constrained devices. And an example of that is in-cabinet applications where you have contactors, push buttons, and so on. So it's an SPE application that is reaching to a cabinet, minimizing the wiring, the space being used and in getting Ethernet to these, to get diagnostic. I mean, it's huge. And you can't talk about Ethernet and connectivity without talking about security. I mean, they go hand in hand, because later on we're going to address, I mean, this is part of the challenge and the fear, and you have to have the security and security. And so this has been a focus of ODVA, and that's why we have SIP security, and SIP security has been enhanced over the past several years to provide the the authentication, authorization level, and even role for who can change what, and so on, and authorization, making sure that the right devices are on the network and so on. What we do as well to promote the adoption is the education and training. We offer online training all the time, whether it's about quick start, Ethernet IP, SIP security, safety, SIP safety, and so on. Depending on the application, we invite people to attend those. They're free, available, virtually. There are many other areas that we are collaborating. I'll probably speak a little bit more about that. But this is, again, this is, the responsibility of the SDOs is coming together, not only with our membership, but to extend, the collaboration with other organizations, to work with them to make sure that we are helping the industry. And we have collaborations on, whether it's the APL that really took, all the organizations, the major organization work together with 12 industry partners, over several years, a lot of investments to bring this to reality. This is kind of some examples. I'm sure we have more.
Yeah, I'm glad that you mentioned that, because if you talk about going back again to the simplification and whatnot, and what our previous panelists talked about, and I think we've established that there have been products that have been in existence that support digitalization since way back when, right? But I think there's still that unknown, and you touched on the educational portion of it. And I think it's a necessary evil for us, because historically, as an industry, we always play that shuffle game, right? We're always like kind of dancing. We know that technology is great, but no one's willing to make that first step. What do you think it's going to take for someone to actually make that first step? Coronavirus certainly exposed how the lack of inefficiency in terms of the manufacturing technologies. But what else? Well, what else do you think are some of the things that could potentially overturn that shuffle game that we typically play, that's hampered our ability for mass adoption?
From my perspective, the first panel kind of brought it up, the labor shortage, especially, a lot of the experienced maintenance people, or maybe machine operators. They're starting to retire, and all that knowledge has always been inside their head. Hasn't really been transferred to the new employees coming in. Even something as simple as like at a bakery, right? A big industrial mixer mixing up dough.
Yeah.
The operator would just know that, you hear this thing going, all of a sudden you hear the motor go, and then he would know that the viscosity of the dough was just right. So he would manually stop it. Now, if you looked at the electrical profile of that mixer motor, you would see once that kind of grinding noise begins to start, the kilowatt value of that motor starts to rise, that the load of the motor is rising. And so by knowing that, you can kind of automate the whole mixing process instead of having an operator just listen for the sound. If the kilowatts all of a sudden shoot up, I'm going to stop the process, dump the batch, and start the new mixing process. So it's simplifying and making things more efficient from a manufacturing process perspective is one way to start.
If I can add on to that, then same thing. Yeah, definitely. There's a lot of knowledge that's leaving the industry, and tribal knowledge is sacred on some of those pieces of equipment. Those are the start small places. Those are, if you're not sure if that's a main bottleneck at your facility, if you're not sure about that, start with something that where somebody is leaving, somebody, you know, that there's going to be some absence of knowledge. Put that in as an example. How would you look at that mixer? Look at it. You can look at the vibration side of it, of the motor. That's going to tell you a little bit as it works harder. It's going to be less impactful than current draw. Current draw is a great tool because you can utilize that as your measure. That's your start small. So I have a problem. We lost the knowledge. How do I maintain this? How do I keep it going? Let's start monitoring, but do the monitoring in small steps, measured steps. And then you can look at that and go, that was pretty simple in implementing. How do I do the next thing? We tend to overcomplicate. That's the other thing that we do in the industry is we do a bit of the shuffle game. You know, we're kind of we use the phrase quite a bit at Banner. We eat our young every day. In other words, you know, we come out with something and then we build something that is a little bit better than that the next day. And that may supersede the previous product. So when we look at that, it's the same concept of I want to go ahead and make something better, simpler, easier, faster. I want to make it simpler. But to do that, you know, and then be able to implement that into the field, that's where we kind of get lost. We think we make things a little bit more complicated than they need to be. Again, it could be that simple thing where we lost the knowledge of when the dough is at the right spot. Let's automate that. So, and how do you do that? Well, it could be very complex. And people are going to come in and say, you need my big system. You got to do this. You got to bring it to the cloud. No, you need to put it on and have a little light that turns on that says, I'm ready. You know, and embrace the little steps. That's going to get you to the next step, to the bigger step. Because eventually you do want to get that information and utilize all that data that's available there. But everybody is thinking they have to jump in to the wide end of that inverted pyramid. They think they got to get to there. You have to start down at the bottom, regardless. And somebody said it earlier in the start of it. If you skip step 2, you're going to have to come back to step 2 regardless. You know, and the other nice thing is the way products are introduced today, the way they're rolled out. There's so much information on them out there. There is so much information on your application and how to solve that application as well, that it's not like algebra class anymore. If you miss day 1, you are not lost for the whole semester. You can come in, you know, all the way, you know, at the end of the semester, and there's going to be a lot of tools to help you do this. So it doesn't have to be confusing. It doesn't have to be, here's a whole pile of stuff that you're going to do. Tell me if that dough is at the right consistency. No, just start small, start easy, then learn from that one and grow from there. I think that's a big message from the first panel too. Learn from what you start to implement and work from there.
I think another perspective is like the machine operator. I think they're being tasked with doing more and more troubleshooting of their machine. You know, maybe 5-7 years ago, like a toilet paper rewinder, if it would stop. I came from Green Bay, it's the toilet paper capital of the world. So my neighbor was a rewinder operator, and he was explaining to me, like, you know, 7 years ago, if machine stopped, well, he'd just stand back, call it maintenance, wait 20 minutes, they'd come and try to fix the machine. But today, I mean, he's responsible for the first line of troubleshooting.
Yep.
And so he'd like to know, all right, was it a phase loss that stopped the motor? Was it an overload that stopped the motor? Was it a power spike? So he needs to help figure out, troubleshoot the machine first. And if he absolutely can't figure it out, well, then he'll call maintenance. But then he's also responsible for helping maintenance, like swap out the motor and replace stuff that they find that needs to be replaced. So the machine operators need to be more intelligent and smarter, and they're just being tasked more as well. So this is where Industry 4.0 can also help out, where an OEM, like for a toilet paper rewinder, can provide all that information up front on a human machine interface screen to help identify, oh yeah, here's the reason why this thing stopped. Let's get it fixed.
You have your metric in terms of what's acceptable and what's not.
Or even telling you, here's why the machine stopped.
Yeah.
Get to that point.
Well, and that's a good point, because we touched on losing the tribal knowledge with Gen X and baby boomers taking, again, the feel for that machine, listening to that specific sound, right? Knowing that, oh, this machine might be in trouble. Having said that, and knowing, again, the benefits of digital digitalization, I want to go back to that initial question. It's very simple. We know what it needs to do. We have all the benefits. But yet again, why do we as an industry continue to get bogged down? Because, the thing too that amazes me is that typically all these industry leaders are in standard bodies working together to define what that technology looks like. The next slice of bread, right? Whatever that thing is. But yet, when it comes to actually implementing it, there's still that stop and go.
Sure.
How do we get over that?
I mean, very true. And even like for the standard organizations, we work through the technology, we release the specification, but there's even from that point, there's still time for adoption and for vendors and manufacturing to start really taking it and implementing. And behind that, at the end of the day, I mean, it's not change for the sake of change. It is, organizations, companies are expected to show a business value, return on investment, and you start small. And it is a costly, and cost is always a constraint. I mean, for these investments, they're huge, and they're going to take a measured approach, and then it will start to pick up. And there are other things that will stand in the way. Obviously, you got to have the work on this being part of your operational strategy, from the top, and seeing value. It's not just, we want to talk about it. It's seeing a value and truly working on it, and start with some pilot and increase the adoption, and work as a, on the organization and the talents. Sometimes if there are resistance to change or other these are things that you have to work on the culture of the organization and bring everyone along. So that's another aspect that it's really important, sometimes may deter adoption, and that is, you hear about cybersecurity and all the incidents that are taking place, and that's really scary. I mean, you're connecting devices. There is homework to be done. You gotta protect the assets. You gotta protect the devices that you're connecting to the network, and those are some consideration.
On the security, if I could jump in real quick, most of the time what we're seeing with customers in the discussion is not on production networks. They, if it ain't broke, don't fix it, and you're not going to touch my PLC and put anything into it or expect anything out of it. So we have to create an overlaying network of those monitoring tools. They might be for overall equipment efficiency. They might be for condition monitoring, vibration elements, pressures, things like that. But they want to keep those separate. They do not want anything coming from a new network, an unknown thing coming in and injecting into that system. So they want to keep them separate today. And that may lend itself nicely because they may want them to go to two different areas. But as we grow and as we're moving past the basics, so customers that have embraced, let's say, condition monitoring and moving it to the Industry 4.0 approach, when they've embraced that, they like it and they want to do more. And so they will start out small, but then they'll all of a sudden, can I talk to the PLC on the plant floor? I want to bring that data in and I want to share it to this group of people over here. And I can't do that today. So how can I? Yep, you can do that. Well, wait, that's a different network now. All of a sudden we're getting these barriers. So those are some of the things that the barriers that are put in place. I don't think it's the technology that's stopping them. I don't think it's, excuse me, I don't think there's a lot of hardware that's stopping them today. I think it's a lot of mindset and a lot of that, the discussion on the security side, because they can exist in two different worlds and the data can go two different places. Eventually, they are going to want to sew that data together and say, we made this many widgets today. This is what our machines were, their uptime were. How do we blend all of that together? And that will come down to security and pulling data off of a production network, marrying it with another network that might be there. And That's a big element.
And it's understandable,
Yes.
right? Because a single breach can cost you millions and millions of dollars.
Absolutely.
But to your point, as you look at how do we merge IT and OT and still be able to obtain security and that comfort level? Because I think, and again, you guys touched on it, and certainly our first panelists talked about it, but how do we get there?
You know, I think the ODVA did a great job with the SIP security protocol.
Yep.
So this is how you can make sure data goes to the right place or the right person with the right authenticity. In fact, they made it really easy to set up. You really just take a piece of software called the SIP Security Policy Manager, and you just say, yep, this PLC is going to talk to this overload relay, and only these two things will ever talk to one another. In fact, I was trying it out personally, and then I wanted to add a second overload relay to the network. And unfortunately, I forgot to put my my programming PC as part of the security policy. So I was totally locked out. I couldn't add, subtract, do nothing to it. So
So it worked.
It worked.
oh, it worked beautifully. I had to reset everything to factory default to add stuff.
Yeah.
So it works good. Yeah.
Well, and that's one thing that we're seeing too, is that people, again, they're adopting the newest technologies, or they may be, again, there's some people that are having that pause or stall them out as they talk about the security elements. But then there's other ones that are like, well, we'll just keep the data inside that. We'll keep it all into this for today, and then we can move it forward. But they don't want to stop that gathering of the data. They don't want to stop harvesting information or prevent them from starting that. They're going to go with that, but they may move today through the PLC to a historian, but in the future, it might be completely separate. They don't want to feed through an existing device. But there are a lot of things like the tools that are in place, again, the hardware, the software pieces, the protocols, the specifications, they're in place to do it today and do it safely and quickly.
You know, I think another area that's kind of causing customers to not implement this is, you know, you touched on it. We are gathering data already today, but it's a lot of information. What do you do with it? And have you ever programmed an HMI device before?
Oh gosh, way back when.
Right? I mean, it's not an easy task. If all I want to do is have an alarm screen pop up if an overload trips.
Uh-huh.
I mean, it's a lot of steps to do that.
Yeah.
So one of the things that we're trying to do at Rockwell Automation is kind of automate that process. In fact, there's a technology that we call it's Factory Talk events and alarms, where if you use Allen Bradley components with an Allen Bradley PLC and an Allen Bradley HMI, if an overload were to trip, the HMI would automatically just pop up an alarm screen saying overload tripped without programming anything. And so that's kind of the direction that Rockwell Automation is going. And let's simplify that programming process. Let's just not even have you do it. We'll just do it for you automatically if you enable it.
Take out that complexity, make
Yeah.
it simple, and let them embrace it.
So I want to touch on that because we briefly talked about single pair Ethernet and taking it back to, again, the tribal knowledge. As we all know, the prior to industrial Ethernet, as we look at that automation pyramid, right? So typically you have your from office environment to probably the control level, it's industrial Ethernet IP. But then from that portion on to the field device, it's anyone's guess as far as what communication protocol is being used. And let's face it, those are I used to commission them and it was just a nightmare. So again, going back to single pair Ethernet and what it's supposed to do of streamlining that so that what you have one communication protocols to rule them all and simplify. What else do we need?
Yeah, you know, that's a great point. You know, our vision is to put every Rockwell product on Ethernet. I mean, even down to a simple green start push button. If you use standard Ethernet today, I mean, it's you know, it's expensive, right? You have a $20 push button. Who's going to pay $200 to add that to an Ethernet network? But that's where single pair Ethernet comes in. I mean, it's a great technology. It's very cost effective, and it allows us then to put this green start button onto a real Ethernet network. And now you get all the benefits of an Ethernet IP network into a control system. So instead of just having some 1 0 thing show up in your PLC program, it actually will say button pushed in, button pushed out. And maybe even take it to the next level where, you know, like at Six Flags, all the operators are always pushing a big green start button, right, to start every ride. So it's being pushed a lot. I mean, there's only so much life you can do with this
Yeah.
start button. Imagine this, what if we could tell you that, oh, hey, your start button is starting to come to the end of its useful life. We'll pop up a warning automatically with factory talk alarms and events to say that the next maintenance cycle, hey, you need to swap out that push button.
Again, simplification.
Yeah, and we just do it for you automatically.
Yeah.
Right.
And if I can, from our side, we're a sensor manufacturer at the heart of it. And what we're looking at is even if it's not our sensor, from that standpoint, utilize what you've already vetted and trust and have implemented. But even to that point, taking your existing stuff, because it'd be great if on Thursday we all flipped over to that and all the machines were suddenly upgraded. We know that's not going to happen. So one of the things that still has to be, kind of taken off the table is that element that's inhibiting people from moving forward is how do I take my old stuff and make it that. And that your vision is kind of exactly that, kind of plug and play with the end devices. Our vision is along those same lines, but also let's utilize the stuff that's there, but make that connection, get the connection as close as we can to the end device without them having to reinvest in every end device.
Sure.
So, it may be kind of it's like the compromise. Our end goals are the same.
Yep.
But in between, how do I make what's there, how do I make what's there compatible with what's coming is a big key. And that's one of, I think, our biggest elements that are holding people back too, is compatibility going forward. And
That's something that we're trying to address as well, with a nice green start button, right? It's been around for 40 years.
Yeah.
So what we just want to do is you can still use that same button, but you just connect a different accessory
to the back, exactly, the conversion side.
Right.
So we have a couple of questions here. We can make it a little bit bigger. Blind. Here we go. So digitalization seems to be a tool for predictive maintenance, but does it have a weak aspect? Our production engineer, what would be the return on investment to implement a predictive maintenance solution when there are still chances that I can still face a line down?
I think it actually kind of comes down to the cost of unplanned downtime.
Mhm.
I mean, if it's just a small conveyor and you're just moving a few boxes, if it goes down, no big deal. But like a paper machine, I mean, that's an expensive thing to go down. Any little thing I can do to prevent that thing from shutting off unexpectedly, it's well worth it. But I think it all comes down to the cost of unplanned downtime.
Yeah, and from our side, the return on investment is different for everyone on the plant floor. The maintenance person has a different return on investment for what he's doing. HR is involved from a safety standpoint. Everybody has kind of got these different measures that they want to work with. And from the standpoint of how do you work towards like from a reliability engineer standpoint, how do you give them the tools to do that? It's again, it's kind of that start at your worst case scenario, fix that one, monitor that one, get some insight and information. Because once that data is there, now it can be moved and it can be handled appropriately and put through a system where it can go all the way to the top and all the data can flow up there. But without that, you're in the same spot you were yesterday.
Yeah.
And you're just purely reactive. And the reaction times are slower, reactivity, or I should say, I'll be like RC. So reactivity, if we want to think of a different phrase to it, but just being reactive only is not going to get you down the road. And that's one of the biggest things that's stopping, the slide with we moved over 100% productivity and then we dipped back down. Well, being so reactive, you're always going to be below 100% because you can't achieve that next level. And that's what it's going to take to get over that, start understanding, monitoring.
So I want to go back to challenges of mass adoption. So we talked about cost, and I'm sure we've all heard about this, right? In terms of, this is new technology, but that's a new capital expenditure. I still need to be able to prove out what that ROI is. Someone made a comment earlier that the cost of solutions that can support digitalization, if I can say the word, is actually going down. But yet, there's still that notion that it's expensive. What do we need to do to combat that or get rid of that perception? Because perception is reality.
Yeah, so one of the things with the cost of doing condition monitoring today, and so we'll focus maybe on that predictive maintenance side of it. The cost of that has dropped dramatically. Couple things. One, consumer products have opened up the door. There's that discussion early on today. Consumer products have opened it up on accelerometers. So when you pick up your phone, it turns on, it's an accelerometer. Same type of technology is being implemented in the industrial side now. Now that the commercial and consumer side has put millions of products on the table, now that reduces our costs. So we can start doing that in an effective fashion. We can industrialize it, if you would. Taking that cost out there, the sensors have always been available. Vibration sensors have been available for 35, 40 years, easy. The connectivity part to that sensor could be 3, 4, 5 times the cost of the sensor itself. The installation would be, I'm not sure how to do it. There is a lot of barriers on the cost side, let alone lack of knowledge. Today, you can get the reduced cost in the vibration sensor. You may want to deploy a wireless approach. So you save on hundreds of feet of cable and do that. And that gives you the ability to reach around and start moving data differently. But there's a lot of tools that are bringing the cost down in this whole market, let alone the ability of saying, I want to do analytics down on the ground. I want to do it in this controller physically right here. I don't have to have a cloud tool to do that. I don't have to have my reoccurring costs every year for monitoring. I can do it here, and I get a simple green go, red no type of approach, or handshaking over to a PLC, going to the HMI and saying, there's an issue, take a look at this.
I think also that a lot of end users, they actually have a lot of smart stuff in there now. They're just not really using it to their full advantage. It's just kind of taking that next step. But the data is already there at their facility. They should just use it, right? And so hopefully examples of what we talked about today will help inspire some ways where they can use this information.
And we could take this in so many directions. Again, and at the end of the day, it's like, again, it goes back to that question. How do we overcome these challenges that have pretty much paralyzed our ability to move forward? And I guess that's the magic question.
And I think part of what we're doing today is helping the cause. I mean, this is part of the education. This is part of the awareness. This is part of sharing those who are on that journey and have successful use cases and applications to share with others so they can bring them along. I mean, this is part of this whole collaboration and everyone coming together for to make sure that this is successful.
So besides that, educational, no doubt, is a big component of it. What else do you think?
But you mentioned though, education. Right now, today, manufacturers will come out with a product and they'll go, we have a vibration sensor. Magically, everybody is supposed to know what that does, where it goes, how it works, what can they get from it from a value. Our biggest successes at Banner come from educating the customer. So when they call up and they have the old, think big thing going on in there, and we're like, throttle it. Let's just slow down a little bit and let's understand what you really want to do. And then let's talk about what that is. Let's educate them on a good, successful path. We have enough history in this in IIoT now as an industry overall, that we can now have measures and we can look at and say, here's where it's been successful. Here's a great success example. Here's what they did. But what they also did, they had people that were knowledgeable. They informed their people. They got buy-in, if you would, from top all the way down. And everybody was comfortable with what they were going to be doing in their layer. If it's the person who's installing it, he's comfortable with how to install it. If it's the person that's going to be sewing it together with the rest of their control systems, they're comfortable with that. If it's the one digesting the data, they're comfortable with what that data, and if they're not, go in and educate them and get them to a comfort level. And that is one of our biggest barriers today, is that like I mentioned earlier, we make it way too complicated.
We make it way too complicated, and yet we all agree that we need to share what those success stories look like so that everyone can say, "Yeah, you know what?
Yeah.
Maybe I'll start out with that one yet," right? But yet, I think we're so conditioned to sort of keep that information inward.
And we're maybe a little bit different at Banner. You can go on our website and stuff, and you can just look at solutions, and you'll be inundated with them. You're like, which one do I choose from? I mean, it gets to that point now.
Mhm.
But there is a lot of information out there on successes. Whether it be a company-driven success story. So something, as an example, Banner may develop, or there are a lot of conversations, a lot of forums that are out there, and a lot of organizations as well, to help people understand what they can get from monitoring, whether it be productivity side or be kind of a predictive maintenance side. There's a lot of forums, there's a lot of education tools out there beyond the manufacturers as well. And start at the manufacturer. A lot of them will give you the guidance on, we are members of this organization.
Mhm.
Those are great tools to go look at and say, where can I get more insight?
Knowledge share.
We're running out of time here, but
We're getting the hook, huh?
yeah, but I know just in the next few years, there's gonna be a lot of exciting things coming out specifically on single pair Ethernet, like
Mhm.
Ethan described. It's gonna take what we have now, but just make it even easier for lower end devices, simple as a push button, right? We're trying to make it easy for the end user.
Well, 100%. And I think this is where maybe we wrap it up. I want to bring it back to the role of a standard body like ODVA. Would that be the perfect forum, or is that the ideal forum to share those use cases, to share those success stories so that everyone's looking at it? What else can we be looking at? What other avenue besides our own respective websites touting our own success stories?
I would say, yeah, that's ODV.
I'm gonna say probably, successful stories. I mean, there are so many forums for that, whether something like this here, the IoT World Congress, so many other events are out there where the standard organizations, we would invite our members and other organizations to work to continue to enhance the standards and develop the technologies. So to come and participate and be active, with the organizations to continue to bring the technologies forward and to solve the pain points of the end users. I mean, there'll be some of that, and this is the forum to come together and develop solutions.
I know for us, you're always welcome to come to our automation fair. It'll be in Boston next year. If you want to see all of our stuff live and up and running, it's free. We even give you a free lunch. So,
As we talked about at the beginning of this session, this is a hot topic and we could go on and on. It looks like we're out of time. So again, panelists, I appreciate you sharing your knowledge. I think this is a very important topic for us to address in terms of, again, helping move the industry to start realizing the benefits of Industry 4.0. So again, thank you. And to our audience, thank you very much for joining us. This concludes our Industrial Ethernet Week discussions today. I want to encourage you to join us again tomorrow as our subject matter experts will discuss innovative technologies for Industry 4.0 going forward.